Good morning, sir.
Yeah, good morning. Good morning, everyone.
Good morning, sir.
Yeah. All right. So today, what we will do is we'll look at compound data types. All right. So what are the data types we have seen thus far? We have seen the primitive data types, isn't it? The basic data types. So what are these data types that you have practiced with? Anyone?
Int, float, characters.
Int, float, characters. Then Boolean is also a data type. Anything else?
None type.
None type. Very good. One more.
Complex.
Complex. Okay, excellent. So these are the primitive data types. So now what we will do is we look at some of the compound data types that Python offers us. Okay, so these primitive data types are good for the basic purposes, but when we want to do some projects and all that, we should have access to more data structures. Okay, so there are some inbuilt data structures or data types that Python offers us, and these data types are compound data types. They are known as compound data types because, as you will see, they are not the raw data type. They are not an int or a float or a complex number or any of this. Okay, but they look like sequences. They can take multiple elements, so they are known as compound data types. Okay, so Python offers us many compound data types. Some of this you might have seen in other languages. So I'm sure that most of you, 90% of you, have studied at least one programming language, isn't it? Okay, or 75% of you. So all of those who have studied a programming language will know that there are some inbuilt data structures that the language will offer. So these can be like a linked list, or it can be like a set structure that is offered us. Okay, so there are many examples of data structures that the language will offer. Python offers a variety of compound data types, and today we will look at one such data type, which is very commonly used in Python. Okay, so some of the data structures that Python offers include a list, tuple, dictionary, set, okay, and strings. Okay, all of us know about strings. Strings are nothing but they contain multiple characters. As you saw, a primitive data type is a single character, but a string is just multiple characters. In fact, there is no character data type in Python. The character data type is basically a string of length 1. So any string of length 1 is a character, isn't it? So there's no separate character data type. So unlike in C, where you have a character data type, oops. Can you hear me?
Yes, sir.
Yes, sir.
Okay. Okay, I just temporarily lost connection for some reason. Okay, so as I was saying, we have a lot of compound data types in Python. Okay, and the first one we will look at are the lists, and we'll do it hands-on. So please open your idle, okay, and be ready to program with me as I show these statements. I will also be doing. You can also try it out. Okay, so that's what we will do. We will do a hands-on exercise in introducing one of the key data types in Python, which is a list. Okay, so those of you who have done other programming languages will know that each of these languages will offer us different data types. And list is a very common data type that is offered by most of the languages. Python has a list data type that is unique in certain ways, and we'll see its properties. Okay, so I was presenting, but I don't think now I am presenting. So let me just activate the presenting again. All right, so all right, so let's go into this list data structure in Python. So all of you open your idle. Okay, I'm going to now go to the script. Okay, and we will be doing the script. I have a script and we'll be doing it in the idle editor as well. Okay, so I also have an idle editor where I'll be typing the commands. Okay, so what is the list in Python? Basically, it's a sequence of elements. Okay, it has multiple elements denoted by square brackets. So anything you put with square brackets is a list. Okay, and the properties of the list is that the elements within the list are ordered, meaning that you can index a element in the list and you can retrieve the element because it is ordered. It is iterable, meaning that you can move element by element. So since the elements are you have so many elements and you can just move index by index, so it becomes iterable. It is also mutable. So what is this mutable thing, isn't it? It sounds like a biological property, but what is mutable? It means that the elements in a list can be changed. Okay, suppose you have in the second position of the list you have a number 3. You can reassign that number to be 5. Okay, so you mutate the elements in the list. You can change the elements in the list. That's what is meant by mutable. And finally, it has the property that it can contain multiple data types. Okay, a single list can contain numbers, can contain strings, can contain another list. Anything it can contain as its own elements. So it can contain all other data types as its elements. So it does not have to be a list of only numbers or list of only strings. Of course, you may have a list of only numbers, isn't it? But it need not. Even if you have a list of numbers and strings mixed in as different elements, that list is okay. So a list can contain multiple data types. It is ordered, it is iterable, and it is mutable. So we'll see examples of all these properties. Okay, so how do we create an empty list? Okay, so empty list is created in 2 ways. Okay, and first you can either give a empty square brackets, then that will create an empty list, or I can just use the keyword list of, and that will initialize the empty list as a list. Okay, Python is dynamically typed, isn't it? So sometimes this is not necessary, isn't it? But when you want to call this particular list and add elements to it, then the type of this variable should be clear. So usually we do initialize a list. Okay, so we know that variables are dynamically typed, but when we want to perform operations on the variables, then that type of the variable has to be known. Okay, that is when you want to add something to this variable, then this variable type should be already known, isn't it? It's like when you're using some variable inside a loop, you're saying x is equal to x plus something, and you're using x on the right hand side, then the value of x should already be known, isn't it? All right. So let's do this. So let me create a list called planets. Let me initialize the list. So let's go to our console and say planets is equal to an empty list. Now I say type of planets. Okay, and it tells me it is a list. All right. So all of you are doing this. Are all of you doing this?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, please try it out in your idle as well along with me. Okay, follow the class and do it. Okay, so now let's populate the planet list with some planets. Okay, so I'm going to say these are the elements in the planet. Let me say it's a list of only strings, isn't it? Okay, so I say planets is equal to Earth, Venus, and Mars. Okay, so now I just say planets or print of planets. I'll get the same thing. Now there was a question that was asked by Keshav, who asked that whether I say x or print of x, isn't it? It gives me the same value. So what is the difference, isn't it? Okay. Now there is a difference between x and print of x. It depends on the object, isn't it? If x is the number, it doesn't matter. Okay. Print of x basically will print the string representation of x. Okay. So every object has a string representation. If you take a number, that number, when you print, what you see is the string representation of the number. Okay, so print basically goes to the display representation of the number of the object and does it. Okay, so it may be different from the object itself. Okay. Now, when you want to print the object itself, it will only give you, the value in the object. If the object happens to be a function object, it gives you the memory address of the function because there's no value for the function. But the function name is still a variable, is still a object in Python. So it will give you only the memory address of the particular function. So just saying X will not be very useful. Okay. So X will only work certain times. Okay, to be on the safe side, you always have to say print of representation of objects that we create. Okay, when we go into object-oriented programming, we'll be creating our own classes. And when we say print of a object of this class, we'll see how to modify how the object gets printed. Okay, so we'll see all those techniques. But let's get back to what we are doing. Okay, so we are creating a list and populating it with the planet names. Suppose I want to find the first element in the planets list, then all I have to say is planets of 0. Okay. Now, and it gives me the Earth. The first element is return. Okay. Now, now I have given this command and I've been able to retrieve the first element. From what I have done, what do you observe? Is there any observation you can make?
Sir, the first element is 0.
List starts from 0, 1, 2.
That is, we can make an observation about the, yeah, so the indexing in Python, isn't it? So the indexing in Python starts from what? Starts from 0. Okay, so the indexing starts from 0. So there are some languages where the index starts from 0, some languages where the index starts from 1. Any of you know a language where the indexing starts from 1? Do you know a language where the indexing starts from 1? Anyone? No one? Okay. If you take R, in R language, the indexing starts from 1. Okay. So R, the indexing starts from 1. So that's the key difference between R and Python. So when you move to R, you have to be careful about the indexing. Okay. But it's a simple difference. Okay. So like this, there are some basic differences, isn't it? Okay. All right. So the indexing in Python starts from 0. So keep that in mind. All right. So now we can just give the index and retrieve the elements. So when we want to retrieve the elements, see how we are indexing. How do you index? You give the variable name, that is the name of the list. Then you index it by using the subscript operator. Okay. Don't get confused with the brackets, square brackets we are using here to initialize a empty list. This square bracket is called a subscript operator. That is, we are trying to index some data structure. So any data structure that has a sequence of elements can be indexed, isn't it? So to index any of these data structures, we use the subscript operator. Okay. So what is the subscript operator? The subscript operator is the square brackets. Okay, and you have to give the index here. Okay, within the square brackets, you give the index. What is the number that you want to retrieve? And you give it within square brackets. So therefore, that square brackets is called the subscript operator. All right. Okay. So I'll put that here in the notes, isn't it? So to examine it, so I'll say subscript operator is the square brackets. Okay. So now I say planet of 0 and I get that particular element. Okay, you see it's planets of 0. Okay, so read the subscript operator, we say planets of 0. Of 0, isn't it? That is the 0th first element I want to return. Okay, which is indexed by 0. All right. Suppose I want to. Okay, so here that's what I've said, isn't it? So the subscript operator for indexing is this one. Okay. So that is clear. Now, suppose I want to find the number of elements in the list, as I say, len. So len is a function that Python provides, inbuilt function to find the length of any, of these compound data types. So I say len of planets, isn't it? Okay, and I get 3. Right? Okay. So now suppose I want to modify a list. Okay. So let's say that I want to change the second element to isn't it Mercury? So let's say then I say planets of, how do I index the second element?
1, sir.
Planets of 1, sir.
1
Yes,
is
sir.
equal to Mercury. Okay. So I say this. Now I print planets. I can just say planets or print planets. Now you see this change. So a list will allow me to find the elements. Elements in a list can be reassigned. You may think that should always be possible, but there are some cases where we don't want elements to be reassigned. Okay, so that you maintain the structure throughout your program. And there are some data types that will allow us to do that. But a list, as far as we are concerned with the list is mutable. All right, so we can reassign the elements in the list. And the list is ordered, that's why we are able to index the list. The list is iterable, meaning we can use it in a for loop, and we'll do this after we complete all the data types. We'll see how the list and other data types are iterable. They can be used in a for loop. This is another Python feature where the data types themselves can be used in a for loop. Okay. Now, list can also contain multiple elements. So let's say planets. I want to add something to the planets, isn't it? Okay. So I can, let's say, suppose I say planets of 3. What does this mean?
Sir,
You are
I'm trying to
adding a
add
fourth element. Fourth element.
Yeah, I'm trying to add a fourth element. Let's see if I'm able to do this. I'll mix it. Okay. So when I say planets of 3, okay, I get an index error because we still don't have the index 3 in the planet. That is, the fourth element is not there. So I cannot do that. I can reassign an existing element, but I cannot randomly assign a new index. Okay, that is not possible just by using the subscript operator. Now, suppose I want to add some new elements to the list. It is possible because the list is mutable after all. So you can add new elements, but not in this fashion where you directly give a new index and then try to add, because that index does not exist. Okay, so it returns the index error. So first we have to initialize the index, and only then we can add elements to the list. Okay, so for all this, okay, so now we come into so we know how to create a list and add elements to and populate the list. Okay, we just say planets is equal to all this, and we initialize the list. Now, after we initialize the list, okay, now we want to do a lot of operations to the list, like add some elements, okay, maybe delete some elements, find find whether a certain element exists in the list or not. So many operations we want to do with the list, isn't it? Okay. So to do all these operations, we have to go back to our fundamentals of Python, where we said that if you want to access a particular function within a module, we have to use the dot operator. And that same logic applies to objects that we have in Python. A list is an object, isn't it? And if you want to do an operation with the list, we have to use the dot operator and access the method. Okay, so the functions that are available for objects, specific objects, those functions are called methods. Okay, so in Python they are called as methods, and each object has a list of methods that we can use with the object. Okay, and if you want to use a method on an object, okay, then we have to use the dot operator. We have to say that object dot that particular method to call that particular method on the object. Okay, so there are some operations we can perform on each object. Okay, list has a set of operations. Dictionary, which is another Python data structure, has a set of operations. So when you want to do these individual operations, respective operations on the object, what we can do is we have to use the dot operator to invoke those methods. So when you want to invoke a method for your object, we have to use the dot operator. Okay, so let us see some of the methods that are available for the list object. Okay, so this shows a set of methods for the list object. Okay, so these are the functions that are available for a data object. They're known as methods, and they are accessible by the dot operator. Okay, so first thing we want to do is we want to add an element to the list, isn't it? Okay, so let's say we want to append, and let's say we want to append this. What is this? Let's say we want to append Jupiter, isn't it? Not the environment, but the planet Jupiter, isn't it? Okay, so we want to append Jupiter with a I, not a Y. Okay, and so that's what I want. I want to say planets of 3, isn't it? I want to say planets of 3 must be Jupiter, but I can't do it in this fashion because it gives me Python will not allow me to do it. The index does not exist. It's called the index error, isn't it? So we notice all these errors that Python returns. So if I want to add a planet Jupiter, then I use the method append for the list object, and whatever I want to append, I give that here. Since it is a string, I put it within quotes, and I close my append. So these methods are like functions, as I just mentioned. So they take some arguments. These arguments are specified within parentheses. All right. So every method has to have some parentheses because every method is a function. Even if it doesn't take arguments, then it will be an empty parenthesis. Okay. So here to add an element, so that particular argument is given within the parenthesis. So I say planets dot append of Jupiter. Okay. So now it does perfectly. There's no error. So let's see what my planets now contains. Now you see it contains the Jupiter. All right. So now I'm able to add. So like this, I can append any number of elements. I can keep appending, elements to the list. But the problem with the append is, but the limitation with append is, I can only append one element at a time. Let's say I want to append 2 more planets to this. Let's say I want to append both Neptune and Saturn, isn't it? Okay, let's try to append 2 elements. Now it gives a error. It gives a type error because the append method takes exactly 1 argument, but 2 is given. Okay. So now if I want to add 2 elements to the list, then what I use is a different method. There's another method that will let me add multiple elements to the list, and that method is called extend. And if I say extend and Saturn and Neptune, extend Saturn and Neptune, 2 elements I'm adding. Now you see, oops, I have to give it within this one, isn't it? Right. So now I say planets. Okay. Now you see extend has a slightly different syntax than the append. Okay. Now if I give append within this brackets, that will not work. It will work as a single element. A single element will be appended. Now you see the difference between append and extend. All right. See, when you do extend, okay, you can give multiple elements, but those elements have to be given as a list. But when they are inserted in the list, they'll be inserted as. Now append will take only 1 argument, so you can append the entire list. Okay. So now when you do the append, you'll find the entire list is appended, not the individual elements. All right. So you see, these are fine distinctions. With append, you can only append 1 element. So you can append the entire list that contains many elements because that entire list is just 1 element. And the entire list will sit in the list as another element. Okay. When you do extend, the syntax is, you have to give whatever you want to extend within a list operator, that is within the square brackets, but the elements will be inserted as they are. Okay. So that is what we want. That is the effect we want. We want to insert these individual elements, and therefore we have been successful in inserting them. Okay. So that is the append and the extend. All right. Okay. So so that is what we have been doing. So now you see the extend syntax here. Okay. So append multiple elements to the end, but notice that we have to notice that the list operator, isn't it, is required. That is the square brackets. All right. Now, suppose I want to insert an element at a particular index. Okay, when you do append and extend, they're only adding to the end. But I want to insert in the middle. There's some index I want to insert. How do I do that? Isn't it? So then what I can do is I can say planets dot insert. Okay, this method takes 2 arguments as it's shown here. First, it takes the index and then what I want to insert. So where do I want to insert? Let's say I want to insert right at the beginning. And right at the beginning, I want to insert Venus. Okay. All right. Now, when I say planets, so wherever what is the position you have given, in that position it will insert. So 0 means at the beginning of the list it will insert. If it's 1, then it will insert between Earth and Mercury. All right. So like that, insert will also work. It takes 2 arguments. Like a function that can take multiple arguments, isn't it? So it takes 2 arguments. You give the index position and the element you want to insert. Okay. So everyone is following me?
Yes, sir.
Yes, sir.
Okay, so everyone be programming along with me. Okay, that is the way to learn. Okay, and then I'll also post the script. You can practice with the script as well. Okay, the entire script will be posted, but unless you practice with me, you're just making it hard. Okay, all right, for yourself, because there's an opportunity for you to learn, isn't it? Okay, now suppose I want to remove a particular element from the list. Okay, then I just say planets and I use the method called remove, and it takes one argument. You have to specify exactly the object that I want to remove. What is the element I want to remove? Not the index or anything, but the element. Okay, these are all string elements, so I have to give a string element. So let's say I want to remove Mercury, isn't it? Okay, so I say remove Mercury. Okay, so now I say planets, and you see there's no Mercury there. All right. Okay, now suppose I want to I want to remove a particular element in some index, not by the element name, but I want to remove a particular index. Then the method for that is called a pop. Okay, so I can do a pop. Now let's first see what is the len of planet. It is 7 because I have 1, 2, 3, 4, 5, 6, and this entire list is taken as one element, isn't it? So we have 7 elements. So let's say I want to pop the 7th element. I want to remove the 7th element. So it is possible to remove a particular index by using the method called pop, and it takes a argument. What is the index I want to remove? What is the index of the 7th element? It is 6, isn't it? 6 is the index. Okay. So now I have removed it. Okay. Now this particular operation, this method will also return the removed element. Whatever element is removed, it will return it. Okay. So you can assign this to something and remove it. Okay. Whereas remove will just remove, it doesn't return anything. Pop will actually return the element that is being removed. So you can assign it to another variable if you wish. Okay. So now let's again print planets. And you see this element has gone. All right. So next thing we want to do. Okay. Now instead of using the pop method, I can use a function itself to delete. Yeah.
Sir, can the remove function be used with the index number?
No, it cannot be. Okay. Remove can only be can only take an argument. What is the object in the particular list that you want to remove? What is the element you want to remove? That element you have to entirely give. Okay. And actually,
So
what it does is you may have multiple instances. Sorry?
It takes a string value, right? So remove function takes a string value.
Yeah. No, not a string value. It has to take the element itself. If the list contains only numbers, then you have to give the number. Which number you want to remove?
Okay,
The
sir.
element itself, you have to give. What is the element I want to remove? Okay. For example, I say num is equal to 1, 2, 3, 5, again 1 and 2, 3 and 5. Okay. Something like this. Okay. And if you say type of num, again it says list. Now I say num dot remove. Now if I want to remove 5 from here, isn't it? Let's say I want to remove 3. Okay. So I want to remove 3. You have to give 3 here. There's no quotes necessary because the element is 3. That exact element has to be provided. Now if you see num, okay, it only removes, it has removed this 3, but this 3 remains. So that means what is the behavior of this method? It removes the first occurrence of the element. It only removes the first occurrence. Okay. So by doing these experiments, you'll find out the exact behavior of the method. And now, if you have multiple, say, elements, the same element is repeated in multiple positions, then only the first occurrence of the element is removed when you say dot remove of 3. Okay, so that is the behavior of the method. All right.
Sir.
Okay. So now let's come back to this.
If we want to remove multiple together, how do we remove it then? So you said there were 2 3s. I want to remove both the 3 with a single command. How do I do that?
Okay. Now let's see. You want to remove all the things, isn't it? So now, since you want to do that, okay, let's try to see how to do that. Okay. Doesn't have a file. Index. All right. So, okay. So it only returns the first one. If you want to remove all occurrences, then what you have to do is, you have to find the indices one by one. Okay. So first you say num dot remove of. Let's see. I want to remove all the true occurrences, isn't it? Okay. So if you look at num, how many twos are there in num?
3.
3 twos are there. So first I say num dot remove of 2. Okay, now it's fine. Now I say num dot index. Let's say num dot remove of some non-existing element. So X is not in list. So what you can do is you can say num dot remove of 2. You can keep repeating the statement until it is gone. Okay. Now how we can do this is you can put it in a while true loop. Okay, and then you can do this. But what you can also do is suppose I say num dot index. Okay, it says it is not there in the list. Okay, so the only way to do it is you have to put it in a while true loop and keep removing until you get an error. Okay, and this error we can handle. We'll see later on that we can also trap these errors, and once there's the error, we can move on. Okay, so otherwise there's not an option to remove multiple elements in one go. You see, it's very useful that this is not the default behavior of Python. Okay, suppose you do have a list where there are multiple occurrences of a given element, and you say remove the element, and all the occurrences are removed, but this is not what you wanted. You only wanted the first occurrence to be removed. Then you will not know which positions have been altered. The entire list will be altered. All you wanted to do was remove the first occurrence. So that is why the inbuilt function method only removes the first occurrence. If you want to remove all occurrences, then we have to write a small script for that. Okay, as I said, you have to keep removing until the whole thing is completely removed. So I say num dot remove of 2 again. Now the final 2, we have already removed the 3 twos, isn't it? So now there's no more 2. It's not there. But I can put this in a program as well and tap this error. And once there is the error comes up, I can move on in the program. So that can be done. We'll do this when we talk about exceptions in Python. Okay. So that is a later topic. All right.
Thank you, sir.
Yeah. All right. So I can remove I can remove an element by name. I can remove an element by index. Okay. Now, instead of using the pop method, I can also use a function in Python to remove this. So let's say planets. Let's go back to planets, and this is what I have. And let's say I want to delete Earth here. So let's say I can use this function called delete. Okay, del, and I can use the planets and the index I want to delete. And let's say I want to delete 1. So now it deletes 1, and now I have planets, and this is what I have. All right. So very good. So now suppose I want to replace the first element, isn't it? So let's say planets. I can replace the first element because the first element is existing. So I can replace it by saying planets of 0 is equal to Earth. Okay. So this is possible. I'm sorry. And I say it's equal to Earth, and I say planets, and I get all these. Okay. So you see that I can reassign the element because the list is mutable. I can also add to a list because the list is mutable. I cannot add to a list by indexing a new index, isn't it? Because then the index does not exist. So I get an index error. But I can use extend and append to add to a list. So in these ways, the list is completely immutable, and you can change the elements in the list, and you can reassign the list. All right. So these are all some of the methods in the list. And suppose I want to create a new list from an existing list. Okay. So now what I can do is, let's say, I can do this. It's similar to extend. Only thing is I'm creating a new list as well. Okay. I want to create a new list from an existing list. Okay. So how I can do that is, you remember the syntax for the extend. When you want to add multiple elements, we have to use the square operator. Let's say the new list is planets. Full list of planets is equal to planets that is existing plus we don't have, it has Earth and Mars and Jupiter, Saturn, Neptune. It doesn't have Mercury and Venus. So I'll just say Mercury and Venus here. Okay, so and I do planets underscore full. You see that now I have at the end Mercury and Venus. So I have created a new list from my existing list. The existing list remains as it is. All right. So now you see that what have I done here? So what do you think the plus operator is doing here?
Sir, it just joins with the existing list.
Concat with the existing
Okay.
list, sir.
So it is adding some elements to our existing list, isn't it? Okay, and returning this, giving it to this particular thing, isn't it? Okay. So in fact, you can just do this. You can say planets plus this, and you see this is what it is doing. So plus is actually concatenating, isn't it? Okay. So the plus is also useful when you operate with strings. Okay. So suppose you have a string x is equal to Python, and then now you say x plus programming. Okay. So now you see it says Python programming, isn't it? Okay. So now you see the plus operator here. When it is strings, it concatenates. When it is list, it adds the elements. Okay. When you have numbers, it adds the numbers, isn't it? So the plus operator has many different functions depending upon the context in which it is. Okay. So that depends on the data type on which the plus operator is working. Okay. So for some of these data types, the plus operator has a different meaning, especially for a list and a string. Okay. So it means that the plus operator can also work as a concatenation operator. Okay. So this facility by which a single operator can have different meanings in different contexts, that concept is called operator overloading. Okay. So that means plus is the operator here, and the operator is overloaded, meaning in different contexts that function. Okay. So when you're adding numbers, the plus will add it. When you want to add elements to a list and a new list, plus will concatenate all elements. When you want to concatenate two strings, you use the plus operator. So that is known as operator overloading. We'll see more about this later on. Okay. So I just wanted to highlight that the plus operator is a concatenation operator here. Okay. So I can concatenate two lists. Okay. And we can have a new list. So in fact, what we can do is I can say a new list, isn't it? A new list is equal to this, what is this?
Excuse me, sir, I have a question.
Mercury. Yeah.
Sir, whether we can use concatenation operator instead of extend, right? Instead of creating a new list, we can update the existing list using concatenation operator, right?
Yeah. No. Concatenate operator cannot be used. It can be used even with the existing list. Yeah. So suppose I say planets
equal to
planets is equal to new list plus planets. Okay. Now you see the planets contains everything. Now this works. This is different from the extend. So this is, as I said, extend will do the same thing. Okay. But this, when you do the new list like this is slower than the extend method, because the extend method works on the existing object. Okay. And then you're extending it. So the extend is faster, especially when you're dealing with large lists. When you're doing like this, sorry. Okay, when you're doing like this, what happens is you're reassigning the list itself. You're first concatenating, and you have this value, and you're now saying this list is reassigned to this entire value. So you're doing many things. You're not only concatenating, you're also reassigning the list to this entire value. So since the list is mutable, you can reassign it. That is all fine. Okay. I mean, the entire object can be reassigned. It doesn't have to be mutable. It's not a proper mutability only applies to the individual elements, but the entire list itself can be reassigned. That is true of any data type. This is just like dynamic typing, isn't it? It's like a new variable. You're declaring it to be some value. That is always possible. Now, what happens here is obviously there are many more operations involved here, so therefore it is slower than the extend method.
Yeah. Okay. Okay. Thank you.
All right. Okay. So we can do all that. Now, suppose I want to find the number of occurrences of a particular object. Okay. So as one of you raised a question, I think it was Mohan, isn't it? I want to remove all the occurrences of 2 in my list. or I want to something like that, isn't it? Let's say num. Okay, so I see that one occurs 2 times. I want to remove both the occurrences. So there is not a single method that can do it for us. But before I do this, I can apply a method called count, and I can find out how many times it appears. And one appears 2 times. Now I know that. Okay, so if I just apply remove once, okay, I say num dot remove once, it is not going to remove all the 1 occurrences because it appears 2 times. So I have to say num dot remove 2 times to remove all the occurrences of. So now if I say num dot count of 1, it will be 0. So there will be no such 1. So now I know I can remove all the occurrences. Okay. So one way to remove all occurrences is first find out the count of the element, how many times it occurs, number of occurrences of the element, then apply the remove so many times. You can put remove in a while loop, while I is less than that num dot count, and then you you say num dot remove, and then you increment the counter, and again you go back to the while loop. Is that clear?
Yes, sir.
So you can remove, you can remove all the occurrences of the 1 as well. Okay, fine. Now suppose I want to find the index of element. This we have already done, isn't it? So I can do the particular thing. Okay, so let's say count for births or something. Yeah. All right. Okay. So all right. So this we have done. Now let's come to so these are some of the methods that are available with list. There are some more methods. Let me show that to you. So let's say planets. So this is the planets we have. So we have it in the right order: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Neptune. So this is in the order of distance from the sun. Okay, so the least distance is given first. Now suppose I want to have the planets. The farthest distance, the largest distance from the sun should come first. So I want to order it by the larger distances. Okay, so then what I want to do is reverse this particular list. So there's a method that will reverse the list, and that is called reverse. It doesn't take any arguments. Basically, it reverses the list. So now if I look at planets, you see the whole list is reversed. Okay, so this is called in place reversal. Okay, in place it is reversed. Okay, and this is again a feature of Python because this is a method of the object, and it takes no arguments, meaning it acts on the object itself, and it reverses the object, and the object is changed. Since the list object is mutable, the object itself is changed, and it is reversed in place. Okay, this happens because the list is mutable. Okay, so this is called in place reversal. I can reverse the entire object. If it's a list object, I can reverse it by using the method reverse. Okay, now I suppose I want to sort this by the alphabetic order, isn't it? Okay, so then let's see what we'll get. Okay, so now again it is in place sorting. I do this. Now you see Earth, Jupiter, Mars, Mercury, Neptune, Saturn, Venus. You see Mars and Mercury, it is a tie M, and then it sorts by the second element, second character. So you see now it is sorting by the alphabetical order, isn't it? Okay, so again it is in place sorting. So this is called in place sorting because it sorts and then changes the object itself. The planet's object itself is changed. Okay, it sorts the planets, and now it returns a new planets, isn't it? The whole planets itself is changed, and that's why it is called in place sorting. There's also a way to do sorting that doesn't change the object but returns a new object that is sorted while retaining the original object. We will see this later. All right. So these are some of the other methods that we have with lists. Okay, so these were all elementary methods. Now we can see some that are advanced methods like reverse and sort as well. All right. Now, apart from these, there are a few more operations that are very useful. Okay, these are not methods but operations, and we'll see what these operations are. Okay.
Hello, sir.
Yeah. What is your doubt?
Sir, if you're going to apply that planets dot extend, automatically what we are applying to the arguments gets added up into the fourth index of the list. So if you're going to put that concatenation, will it get automatically added into the fourth index, or randomly it gets changes? It will get added in the 0th index of that list, or will it be getting added into the first index of the list? Is there any difference, or
no? Extend will only add to the end.
Okay, sir. Okay, sir. Then
Extend will only
concatenation.
add to the end. Concatenation can add either to the, see, concatenation means you have two objects that you're concatenating. The left hand object will be the first, the right hand object will be the second.
Okay, sir. Okay, sir.
Yeah. So that order is already fixed. The plus operator, you have a left operator, left operand, and right operand. So left operand is the first one, and the right operand is the second one. Okay.
Okay. Okay, sir.
All right. So now let's come to slicing. Okay. So there is a, if you want to get not one element from the list, but multiple elements from the list, then we can slice the list. So this is another Python thing, terminology. It's called slicing. I think it may be there in other languages. I'm not sure. Okay. It's also called slicing in R. Okay. I'm not sure about Java, what it's called, but it's a general in CS concept, I think we can call it. So it's called slicing, and you want to get a slice of the elements. Okay. And this is possible by using the slice operator. And the slice operator is the colon operator. We've already seen colon when we want to initiate a new block. That is a different colon. But this is the colon that occurs within the subscript operator for slicing a particular object. Okay, so how do you actually do the slicing, isn't it? So the syntax for the slicing is you have to use the subscript operator, and then you have to give the start index, and then you have to give the end index separated by a colon, and then you have to give the step size for slicing. Okay, so all these start and the end index, and what is the step size? That is, you want to go from start to end. Is it you go one by one, or you go in twos, or you go in every third element? Whatever it is, the step size can also be mentioned. Okay, and all this is separated by a colon. And you see that the step size is optional. If you don't mention the step size, it moves in one by one. Okay, and the end is also optional. If you don't specify the end, it just gives you whatever is the index. Okay, you just give the start alone. It means it gives you only that zeroth element of the zeroth index. That is the first element. Okay, so you see, let's say weekdays is equal to this. So let's now do this. Let me just stick with the planets. Okay, so let's say I have my planets, and this is what my planet is, and it's sorted in the alphabetic order. So let's say I want to have the first sum by index. I want to query it. I get Earth. Suppose I want to get the first 4 elements in my list, then I can do it by saying planets of 0, 3, isn't it? Okay. If I want to get the first 3 elements, I say 3. Okay, and gives me 3 elements. Okay, now you see 3 as an index. Okay, when I say 3 as an index, it gives me Mercury. That is, it gives me the 4th element. But when I use it as the end index, it gives me up to n minus 1. Okay, it gives me up to 3 minus 1. That is 2. Okay, so that is what it means. So the n means index minus 1. Okay, so 0 to 3 will actually give me 0, 1, and 2. Okay, so please keep that in mind. All right. So that is possible. Suppose I want to find out the last element. I don't want to find out the length of the list or anything, but I want to know the last element. So then the last element can be indexed by just adding a minus sign. So minus sign means I'm working from the reverse, from the end of the list. And from the end of the list, I want the first element. So I say minus 1, and will give me Venus, that is here. Okay. So suppose, I want to have the second last element. So then I say planets. Okay, and since it's a second last element, I have to put a minus sign. I want to read it from the end, and I want the second from the end. So now it gives me Saturn. Okay, so I can also do the indexing from the end by just appending a minus sign. All right. Now suppose I want to get every second element here, so I say planets of 0. Okay, till the end, isn't it? So if I omit the end, it means till the end, and I say in step size of 2. Now it says Earth, Mars, Neptune, and Venus. All right. Okay. So all this is possible. Suppose I want from the third element, okay, up to the end of the list. Then I omit the end index. I just say 3 colon. Now it tells me from the position 3. That is the index 3. Index 3 is 4th element, isn't it? So 1, 2, 3, 4. From there, Mercury, Neptune, Saturn, and Venus. So all of these are returned. Okay, so you see I can omit. If I omit the index, it usually means till the end. I can also omit the first index I just say colon here, and I see till 4. That means when I omit the first index, that means I'm starting from the start. I'm starting from 0. Okay, so from 0 to 4. 4 means till index 3, isn't it? So 0, 1, 2, 3 will be returned. So that is Earth, Jupiter, Mars, and Mercury. That is what will be returned. Okay, so there are many variations on the slicing operator. Okay, so instead of saying 0 to 2, I can even omit the 0. So I can just say planets are colon 2, because by default, if I omit the start, it means it starts from 0. Now it gives this. And if it omit the end, it means till the end, isn't it? So Earth, Mars, Neptune, and Venus will be returned. Okay, so like that, you see another example here. Weekdays is equal to Monday, Tuesday, Wednesday, Thursday, Friday. Weekdays of 0. Weekdays of 0 is to 3, means the elements 0, 1, and 2. And till 3, if I omit 0, again it means 0, 1, and 2. Till 3 and till the end of the list, it means elements 3 and 4, because only you have 4, the 5 elements here. We say -1, it gives me the last element. And colon 2, it means it gives me every second element. Okay. Now suppose I want to return the list in the reverse order, then all I have to say is colon the entire list. But in the step size, I say -1. That is, I want to give it in the reverse fashion. Now you see, I'm sorry, I have to give it as planets. My weekdays here is not defined, so I say planets, so -1, and you see it is returned in Venus, Saturn, Neptune, Mercury, Mars, Jupiter, and Earth, isn't it? So that is what I have here. So you see, there's a difference between this and planets got reversed. When I say planets here, the original planets is still there, okay? But if I say planets got reversed, okay, and now I say planets, the planet object itself has been modified. But if I do this, it returns this value, but the original planets is returned. Okay. Sometimes you want to reverse the list and assign it to something else, and the original list has to be retained. And I told you I will tell you how to do that. So we do this by the slicing. You return the reversed list, but the original list remains. Okay. So you don't modify the original list. Okay. So all this is possible. And finally, suppose you want to return the list backwards, isn't it? Okay. There's another function to do this. Okay, without modifying the list, I say reversed of planets. It gives a iterator object. So I want to get the list itself here. So I say list of reversed of planets. Okay, and it gives me planets again reversed. Okay, but if you look at the planets, the original planets is preserved, isn't it? Okay, so again, this is another way to do it. So now we have 3 ways to reverse a list. One way will modify the list itself. 2 other ways will return the reversed list, but not modify the original list. All right. Now you see here, I did something, but I didn't tell you what happened here. It says it's an iterator object. So this is something that is used in for loop, in looping constructs. So if I want to return the entire object itself, I have to apply the list function on it and return the entire list. All right. So more on these things later when we do the for loop and everything. All right. Okay. Now the final thing we want to do is, okay. So all right. So I want to do sorting. Okay, and I want to do sorting so that I don't change the original list. Okay. So I saw planets.sort will also modify the original planets. So I want to do this without modifying the original list, so I can do it. Okay. So let's see how to do it. Okay. So, all right. So if I did planets, now if I say planets, now I see it's been sorted. Now suppose I say I want to sort this in the reverse alphabetical order. Then I can provide some arguments to the sort. These are optional arguments, and this argument called reverse, and I can set this reverse argument to true. And then if I sort, and it will be sorted in the reverse alphabetical order. Now suppose I want to sort it by any arbitrary key. Okay, something I want to use to sort. Let's say I want to sort them by the length of the object, by the length of the element. It is possible to do this by sorting on the basis of some key. Okay, if there's a key argument, there's an argument called key in the sort. If I assign this argument to some function, this function will be applied on each of the objects, and based on the value returned by this function, then the objects will be sorted. So now I'm saying the key is len. So I want to apply this function len on each of these objects, and based on the value returned, I want to sort the objects, meaning that I want to sort the objects, I want to sort the elements by the length of the string. Okay, so let's say this is what I wanted to do, and now if I look at planets, the first will be Mars, which is just 4 characters, Venus 5 characters, Earth is also 5 characters. The tie is broken because Venus comes first. Saturn has 6 characters, Neptune has 7, Mercury also has 7, but Neptune occurs first, and Jupiter also has 7 characters, which occurs at the end. All right. Now this modifies the object. Suppose I want to sort without modifying the object, then I use this function called sorted, and I say sorted of planets. Okay, this returns the sorted list. By default, the sorting is based on the alphabetical order. Now, if I go back to planets, you see the planets is not modified. Suppose I want to use sorted on the reverse alphabetical order. That is also possible. And here I have to use that reverse argument is now given in this fashion because all these are arguments to the function now. Planets is the first argument and reverse is the second argument. Now you see it is doing it in reverse. But if you look at planets, it is unmodified. Now, suppose I want to do the sorting based on the length of the elements. This is also possible. It's the same syntax as we used for sort, except that we say that here the key is equal to the length as a second argument to the sorted. And now you see it has returned it by the sorted. Okay. So now if I look at planets, okay, this is what it has. Okay. So all right, so you see sorted can also return them by the length, which is the same thing. Here it returned by the reverse alphabetical order by the length. And if you look at planets anyway, it is always unmodified after the sorted. Okay, so all these things can be done. Okay, I'll provide the script for you. So all this is fine. Okay, now you can also insert into a already sorted list and keep it sorted. Okay, for this there's a specific module that we have to import and then do it. So this is a very specific application that I've highlighted here. And you can try this out. It's from a module called Bisect, and you can try this out so that when you have a sorted list and you extend or append to a sorted list, this insertion happens in a way that preserves the sorted character of the list. Okay, all that you can try, and you can create a reference to the list as well, and you can copy your list in 2 different ways. And you can also examine if 2 objects are the same, whether they point to the same memory object or they contain the same value or not. And all this is possible. So I'll send the script up to here and you can try it out. So this part you can try out as a homework and you can come for the next class. Okay, so with that, I think our time is up. Okay, so I hope all of you were able to program alongside in your own idle. And if you have any doubts, please post it in the classroom. Okay. All right.
Thank you, sir.
Thank you, sir.
Yeah, so thank you very much. Yeah, yeah. So you can go for your next class.
Thank you, sir.
Yeah. All right. Thank you very much.
Thank you.